Now the next shuffle, shuffle 47, might almost seem too simplistic to even include here in this series on Bessey shuffle diagrams. But that's actually not really the case, as I'll show you. So this is called a packet reversal. And so it means what it sounds like it means, I believe. So if we begin with an ordered packet 1 through 8, and you just reverse the order of the cards. What does it mean to reverse the order? What was on top will be on bottom, and what was on the bottom will be on the top. So one way to reverse the order is to just deal them to the table. Now they will be in the opposite order to which they were originally. And so we get a new ordering, of course. We get 8, 7, 6, 5, 4, 3, 2, 1. Writing this in Cauchy's two-line notation, we obtain the following. Top row is always 1 through 8, and then we just get 8, 7, 6 all the way down to 1. Converting this to cycled notation, we obtain the following. 1 goes to 8, so we have an arrow from 1 to 8, and then 8 goes to 1, so it cycles back around, giving us a, quote, 2 cycle, also called a transposition. 2, where does 2 go? 2 gets sent to 7, so we have an arrow from 2 to 7, and then 7 gets sent back to 2, so we have a second 2 cycle. 3 goes to 6, so we have an arrow from 3 to 6, and then 6 gets sent back to 3, completing that cycle, so we get another transposition or 2 cycle. 4 goes to 5, so we have an arrow from 4 to 5, and then 5 goes back to 4, completing a fourth 2 cycle, or in other words, a fourth transposition. Color coding the digits, we obtain the following. Recall that the color coding of our position values is as follows. Positions 1, 4, 6, 7 are color coded black. Position values 2, 3, 5, 8 are color coded red. This will enable us to detect what has happened with the Bessey sequence structure of the packet. And as a quick reminder here, if the Bessey sequence form is preserved, then this will occur, namely, whatever begins in positions 1, 4, 6, 7, after the shuffle is complete, will still be somewhere in positions 1, 4, 6, 7. And whatever began in positions 2, 3, 5, 8 will stay in those positions somewhere. Now they may be moved around within those positions, but they won't jump over into set A. Now that's different from the inversion, which is being represented here. The inversion occurs if cards originally in positions 1, 4, 6, 7 get moved to positions 2, 3, 5, 8 in some assignment, and vice versa. Cards that originally began in positions 2, 3, 5, 8 get moved to positions 1, 4, 6, 7 in some assignment. So we see here that black 1 goes to red 8, which cycles around to black 1. Red 2 goes to black 7, which goes back to red 2. Red 3 gets sent to black 6, which gets sent to red 3. And then black 4 gets sent to red 5, which gets sent back to black 4. So we see that the following has occurred. Each value gets sent to a value of the opposite color. And when that happens, inversion has occurred. So everything that began in positions 1, 4, 6, 7 get moved to positions 2, 3, 5, 8. And we can illustrate that using a Bessey sequence consisting of zeros and ones. So if we begin with this particular Bessey sequence here and reverse the order of the cards, we should get the inversion of that original Bessey sequence, which should be 0, 1, 1, 0, 1, 0, 0, 1. And we do. The shuffle diagram for a packet reversal is as follows. It's on the bottom row, left-hand side, and what we see here is we have 4 transpositions. So we should expect to see double arrows between 1 and 8, 2 and 7, 3 and 6, and 4 and 5, which is what we see down below. Also, this right here indicates that inversion has occurred. Let me just point out something that I think I failed to mention. Going back to shuffle 45, because of this 6th cycle and that we have a 2 cycle here, this particular shuffle has order 6, which means you would need to perform this shuffle 6 times to return the packet to its original order, whereas shuffle 46 has order 3. Performing this shuffle 3 times will reset the packet, and then the current one, shuffle 47, this has order 2. Performing this just twice will reset the packet back to its original order. And if you think about it, that should be pretty obvious given what packet reversal does to a packet of cards. There is a mention down below that packet reversal is identical to shuffle 22 that we saw earlier in the series. So let's go ahead and take a look at shuffle 22 to remind you of that. In fact, doing this little review will enable us to talk about packet reversals in a larger context that is quite powerful. So shuffle 22 was the pairwise transpose in which we stack from right to left. Okay, so why don't we go ahead and illustrate this? And so this gives you the exact same permutation. You can see that. We get 4 transpositions, 1, 8, 2, 7, 3, 6, 4, 5. And that's what we get down here with the packet reversal. 1, 8, 2, 7, 3, 6, 4, 5. And of course the shuffle diagrams are identical. So let me just perform the pairwise transpose to remind you of how that works. So the pairwise transpose is where you deal 1, 2, you deal out 2 cards into each pile as you move from left to right, and you do 1, 2, 1, 2, 1, 2. Okay? Now, if we stack from right to left, that is simply a packet reversal. So let me just show you that that's the case, and then we'll kind of talk about larger concepts here for just a moment. So we should get 8 through 1. So the top card now is 8 all the way down to 1. So this is precisely a packet reversal. Okay, now this relates to a larger principle, which I call the first shall be last and the last shall be first. Okay, so how this works is if you begin with a ordered packet so that you can see what's going on, what this shuffle allows you to do, and the pairwise transpose is just a special case of it, this is where, if you've seen it before, you're allowed to deal out the cards into piles, and then when the spectator says stop, you deal into another pile, and then they say stop, and then you deal into another pile until you run out of cards. So here, let's say I'm dealing cards, and I say, tell me when to stop, and they say stop right there. And then I start dealing again, and they say stop, very good. And then I deal 1, and maybe they even say stop there, that's fine. And then I deal out the last 2. Now, as long as you stack from right to left, all of this is equivalent to a packet reversal. That's all it is. So we will get that same 8 through 1, 8 on top, all the way down to 1 on the bottom. Now, to convince yourself of that, just perform that shuffle a few times, and you'll see, oh, that's all it's doing. Because if you think about it, just follow, why don't we follow the cards face up? That's probably a good idea. Okay, so we'll have them face up just so we can see them. So if I begin dealing, like right here, and the spectator says, stop. Okay, I stop there, and then maybe I deal here, and then they say stop. And then I just deal out 1, and they say stop, and then I deal out the last 2. Can you see that if we stack from right to left, we're going to recreate that packet, but it will be precisely in reverse order. Because if we stack this little packet on top of the 6, now we have 6, 7, 8. We take these 3 and stack them on top of those. Now we have 4, 5, 6, 7, 8. And if we take all of these and stack them on top of the 3, 2, 1, or the 1, 2, 3, depending on how you want to read it, like that, then you can see that what we'll have is remember, we had 1, 2, 3, 4, 5, 6, 7, 8. Now we have 8, 7, 6, 5, 4, 3, 2, 1. Okay, so it just reversed the order of the cards. So this shuffle that I call the first shall be last and the last shall be first is a really powerful shuffle. And the name justifies the actions. Because the idea is if I deal out, this is the first card dealt. The first shall be last, the last shall be first. Okay, what is the last card dealt? What's this one way over here? And the first one's down there. So the first shall be last, and the last shall be first. So you're just stacking from right to left. Okay, so that's all that shuffle means. And the name of the shuffle is meant to help justify the mechanics of the shuffle itself. Okay, so I thought I would relate that to something that you may have seen already on this channel.